Hello, welcome to this lecture. Here we got spherometer. We just have to find out what is the radius of curvature of this spherical surface by using this spherometer. So before we proceed, let's go for a least count. Least count, and it's very similar to a screw gauge experiment. Here we have got two scales. Again, this is called pitch scale. The vertical scale is actually pitch scale. And we have got one scale called circular scale. Sometimes we refer it as head scale as well. So in a pitch scale, it's in terms of millimeter. This is 0, 1, 2, 3, 4, 5, 10 millimeter, 15, 20. And in the head scale, there are totally 100 divisions we can find out. Now, initially we will keep it as 0 first. The head scale, I'm going to make it to be at 0 of the pitch scale. That's all. Yeah, this is done. Now, number of rotations given to the screw. So this is actually screw. I'm going to give any number of rotations. It's my choice. I can give 3 rotations. Let me give 3 rotations. 1 full rotation. 1 more rotations. And finally, I'm ended with 1 more rotations. So I've given totally 3 rotations. And I have to find out what is the displacement along the pitch scale. So displacement is 0, 1, 2, 3. So there is a 3 millimeter shift along the pitch. So now what is a pitch? Pitch is displacement by number of rotations. Displacement is 3 millimeter divided by number of rotations 3. 3 by 3 is 1 millimeter. That means for every 1 rotation, there is a 1 millimeter shift along the vertical scale. So that is actually referred as a pitch. Least count is pitch by number of divisions on the head scale. Number of divisions on the head scale is actually 100. So least count is 1 millimeter by 100, that is 0.01 millimeter, which is very similar to, which is very same as least count of screw gauge. So we will get the ultimate final value in terms of millimeter when we refer this spherometer. Now, before we proceed, so that is actually formula to find out the radius of curvature. The formula is given here. R is equal to L square by 6h plus h by 2. And we will find out h later. So before that, we will find out what is L. L is actually length or distance between legs of spherometer. So we need to keep on the sheet and press, make sure that all the 3 legs are touching and press them so that we will get 3 points, join them and find out what is the distance between all the 3 legs and take a mean of it and you will get some value. For example, let me say this is 3 centimeter is a distance between any 2 spherometer legs. So that L should be substituted here. Now how to find out this h? Now to find out h, we have to go for 2 things. One is with a curved surface, in the sense we are going to find out what is the radius of curvature of this spherical surface. First we will just place on the spherical surface, we will note down some value and that is going to be h1. Next, again we'll place on the plane surface. It could be a table or anything, but it should be plane. And we have to find out again one more reading. We call it as h2. Then we'll take the difference. The difference is going to be h. That h should be substituted in the formula where to find out what is the radius of curvature of this spherical surface. So initially, we'll keep the spherometer on the spherical surface. Now I have to make sure that all the 4 legs, including the middle one, touching the surface of the spherometer, and it should be balanced. There should not be any imbalance. Now I've placed it. Yeah, this is absolutely balanced. Now I have to refer the pitch scale and note down the pitch scale reading, that is a PSR here, and after that head scale reading, then coming to the formula PSR plus HSR into least count. So now pitch scale is this one. I just refer this as 0, even though it is written as 10, I can refer it as 0, 0, 5, 10, 15, 20. Now down the circular scale is over here. Now it is actually 0, 5, 10, 11, in between 11 and 12. It is in between 11 and 12. So that is actually 11. The minimum value I have to write here, 11. Now HSR is just direct value. Now it is 0. It is between 0 and 10. Now it is actually between 4 and 5. So the minimum value is 4. So I have to write 4. So I can make use of this formula to find out what is H1. PSR is 11 plus bracket open and this HSR is just 4, least count is 0.01. Again 11 is millimeter, 0.01 is in millimeter, 4 is just no unit. So again you will get the values 11.04 millimeter after substituting here. And now I have to place on the plane sheet and make sure that all the legs are touching. I have to adjust that way. Okay, all the legs are touching. Now I can refer what is PSR again. So PSR is 0, this is 5, this is 10, actually it is between 10 and 11. So I have to write the minimum value, that is actually 10. So HSR is now between 60 to 70, this is 64, 65, okay, this is 64. So that is HSR. So I can just use the formula, this is 10.64. So I can find out what is H, the difference, these two, and I can write over here. One more trial also I can do it by placing somewhere else, maybe here, again making sure that all the legs are touching the surface and the sperometer is absolutely balanced. One more trial I'll get one more value. So take the mean of these two. I can go for one more trial, but it's fine for going for two trials. So H one trial, H is second trial. So take the mean of these two, write on over here. So now substituting in all the things in this formula, L, here it is, and next comes with the H, this one. Convert all the things into meter and substitute, and you'll get the radius of curvature of the given spherical surface. That's what I've written here in the case of result. So thank you for watching this. Share this video among your friends so that this could be helpful for all of your friends to excel in the practical exam. Thank you so much.